This is really exciting because I feel like I've never really wrapped my head around how an AMM worked until I really dug into the math behind it. So today for AMM math, first of all, I'll be covering like what is an AMM. Then I'll be going over a buy transaction and we'll be looking at the price, calculating the price from the reserves, and then we'll be looking at slippage. And then I'll do a sell transaction and then an arbitrage. And then if we have time after all this, I guess there's like one other thing I could do. It's like how to calculate, I guess, what needs to go into an AMM to reach a certain price. So like if you have a USDC FTM pair, how much USDC do you need to put in to make FTM reach a certain price? And it's just kind of a fun calculation.
Hish, little interruption. Let's wait people to open your screen. Guys, Hish, share the screen.
Yeah.
Check from there.
Yeah, everyone make sure to open that screen up.
Also, one other thing, are we recording right now?
Yeah, we should be on record. MID?
I don't know if you can talk.
No, I opened your mute, MID. Okay. We are on record, right? Cool. All right.
Cool. So what is an AMM? It's an automated market maker, and it was sort of designed for blockchains specifically because order books could not work in a blockchain. And the reason for that is when you have an order book, you have to check pretty much like all the buy orders, all the sell orders, and then see what is the best one to route the order through. And that's just like a lot of computation. And on a blockchain, you're limited in computation. So you would run out of gas and pretty much everything would just freeze up if you're trying to use an order book on a blockchain. So Uniswap came up with the constant product market maker. So that was the first AMM to kind of enter the blockchain world. And it was probably one of the biggest developments in DeFi. And since then, like honestly, I still think it's one of the biggest ones. So what an AMM is essentially a smart contract, and it holds two tokens. So this one holds FTM and USDC. And so liquidity providers will put in these two tokens, and then a user can come along and just be like, I have 10 USDC and I want Phantom, and then the AMM will quote them how much Phantom they can get for putting in that 10 USDC, and if the user likes that quote, they can take the trade. So I think the biggest difference is in an order book, you're trading with people, and then the order book is like matchmaking you with other orders. But in an AMM, you're trading directly against a smart contract. So you're never actually trading with somebody. And so the formula for this AMM is X times Y is equal to K. It's very simple, very elegant. And X is equal to the amount of token A. And then Y is equal to the amount of token B. And then K is a constant. And that's why it's called a constant product market maker. X and Y can change. So like X can go up, Y can go down, but K will always stay the same when you make a swap. So I'll kind of get into what that looks like. So the first example I want to cover is a buy. And so say that we have an AMM and there is 100 USDC in it, and then 100 FTM in it. So K is just 100 times 100, which is 10,000. And if you want to know the price of FTM in this AMM, you would just do the USDC reserve divided by the FTM reserve. So that would be P is equal to 100 USDC over 100 FTM. And so that would mean 1 FTM is equal to 1 USDC in this specific situation. So now a user comes along and they say, I want to put in 10 USDC. So now we can calculate how much FTM would come out of the AMM and what the reserves would look like afterwards and how that affects the price. So what that would look like is you have 100 USDC plus 10. So that's a user putting USDC in. And then on the other side of the reserves, we have FTM. And we know FTM needs to come out, but we don't know how much. So I'm going to leave that as Y right now. And then all we have to do right now is just solve for Y. Got a big zoom in going there. Okay. So yeah, I'm just going to solve for Y. So this comes out to 110 times 100 minus Y is equal to 10,000. And then divide both sides by 110. So this would cancel out here. And then 10,000 divided by 110 is equal to 90.91. And then we're left with 100 minus Y is equal to 90.91. And then we can isolate Y on its own. So it's Y minus, or 100 minus 90.91 is equal to 9.09. So now we know if a user puts in 10 USDC, they're going to get out 9.09 FTM. And the reserves after this trade is made will then look like this. It'll be 110 USDC, and then it'll be 90.91 FTM because we took out some. And then, so when you multiply these two numbers together, they should always equal K from the beginning. So they should be equal to 10,000. So I can just double check that and make sure everything went well. And it is equal to 10,000. Cool. So that's a simple buy transaction. If you want to know what the slippage looked like, you pretty much, let me just get a new page going. So we had 100 times 100,000. So this is pretty much like before. Whoa. And then after. So if we want to know the slippage, we pretty much just need to know, like, if you were to make this trade with 0 slippage, like, what would you get? And so if you put in 10 USDC and the price before the trade was 100 FTM over 100 USDC, you would get 10 FTM. So without any slippage, you would get 10 FTM. And then with slippage, we know that we got 9.09 FTM. So to calculate the slippage, all you need to do is divide what you actually got over the case where there's no slippage. So that would be 9.09 over 10, and these are both in FTM. And then you need to minus it by 1 and then multiply it by 100, and then that equals slippage. So just to do the math real quick, that would come out to 9.1% slippage. So we can do this all again, but we can have more liquidity. So say like we had 1,000 USDC and then 1,000 FTM. So in this case, K would be equal to 1,000 times 1,000, which is 1 million. And then if we were to just do that same trade, so the user puts in 10 USDC, it would look like this. And then Y would be equal to, I'm just going to do the math real quick. So Y would be equal to 9.9 FTM. So in this case, if we want to calc slippage, it would be 9.9 over 10 times 100. And then that comes out to 1% slippage. So you can see, like, if we have more liquidity, obviously, like, slippage will go down. And in this case, it went down from 9.1% all the way down to 1% by 100xing the liquidity, essentially. So let's move on to a sell transaction.
Hish, before moving on, we got a question which is a little bit directly related to what you have explained.
Yeah.
So
Yeah,
how
yeah.
do we determine K? Is NDR is asking how K is determined in that equation.
Yeah, so K is always determined based on what's in the reserve. So if you have like 1,000 USDC and then 20 FTM, K is just 1,000 times 20, which is 20,000. So K, you can always calculate it directly from the reserve. So it's always X times Y equals K, if that makes sense. And K is a constant. So when you make a swap, K will be the same. So no matter how much I swap between these two pairs, K will always be 20,000. Now, if you add liquidity or remove liquidity, that actually changes K, but it changes it like proportionally. So yeah, that's how K is calculated.
It's like the first snapshot of your liquidity, like the T0, right?
Yeah, so essentially, like, what the AMM will do is before the trade, you know what's in the reserves. So you have 100 USDC and then 100 FTM. You can calculate K from that. And then you can look at, like, okay, this person wants to put in 10 USDC. And you know K will be the same as what you started with, so 10,000. Yeah, and if like other questions just pop up, just let me know, because I'm like looking down at this, I guess,
Yeah, please.
notebook thing.
Please. And Andy, thanks for the answer. So I guess he's good with it. Okay.
Cool. So let's do a sell transaction. But in this case, I'm gonna kind of incorporate like what an arbitrage looks like. So typically for a token, there's like a bunch of exchanges in a bunch of different places. Like FTM can be trading on Binance, it can be trading on other dexes, it can be trading on SpiritSwap. So I'm gonna, I guess, go over what that looks like in terms of arbitrage. And so what arbitragers do is they pretty much try to make money off of price differences among different exchanges. And so what that actually does is it balances out like the prices and kind of keeps them close on all the exchanges. So let's say we have 100 USDC and then 100 FTM. So K is equal to 10,000 because 100 times 100 is 10,000. And then say on Binance, FTM is trading at exactly $1. So a person comes along, they don't have a Binance account. This is the only exchange they can use. They want to sell Phantom. And so say that they sell, let's say 25 Phantom. So what they would do is put in 25 Phantom into the AMM. And then they want to get out USDC. So this would be a minus X. We know USDC is going to be leaving. the AMM. And K from before is 10,000, so this all needs to be equal to 10,000. And just to run through the math, so this is 125 is equal to 10,000, and then 100 minus x. We can divide both sides by 125. This will cancel out. 10,000 over 125 is equal to 80. So we're left with 100 minus x equals 80. And then if we want to isolate x, it'd be 100 minus 80 and equal to 20. So pretty much like 20 USDC will come out of the AMM. So what it'll look like after this trade is now there's only 80 USDC. And now there's 125 FTM. And then K is still equal to 10,000 because 80 times 125 is 10,000. So the price on the AMM now is different than on Binance. So the price would be P equals 80 USDC over 125 FTM. And then that is equal to 64 cents. So now like an arbitrager is going to be scanning all these different exchanges, and they see that there's a big price difference on this AMM. So they're like, okay, I could buy up Phantom on this AMM up to $1 pretty much and sell it on Binance for $1. Let's say on Binance it stays at $1 even after this trade, and I can make money. And that actually rebalances out the AMM as well. So it's good for everybody. So an arbitrager will come along and be like, okay, I can put in 20 USDC. So 80 plus 20. And they want to know how much FTM they can get out so they can sell it to Binance. So I'm just going to do the math on this real quick. So Y would be equal to Y is equal to 25 FTM. So the arbitrager pretty much put in 20 USDC and they got 25 FTM. And then they sold that 25 FTM on Binance for $1 each. So they got 25 USDC out of that. So they instantly made a profit of $5. So that's kind of what arbitrage looks like. Now, I guess one fun thing to do is to calculate how much of an input you need to have in order to get to the an AMM to a certain price. So as we mentioned earlier, price is equal to X over Y. And so these are the X and Y in the reserve. And then we also have X times Y equals K. Let's say that we have, once again, 100 USDC and then 100 FTM in the reserve. So that would give us a K of 10,000. So right now the price of FTM is $1 because 100 USDC over 100 FTM is equal to 1. We can calculate how much USDC we need to input in order to get FTM to $10. So what that would look like is USDC has to come in and FTM has to go out for the price to go up. So that would look like 100 plus X because we know USDC needs to come in, and then 100 minus Y, FTM needs to come out so the price can go up, is equal to 10,000 because K is constant. So what we need to do here is kind of get this going in this equation so we can solve it. So what I'm going to do is just divide everything by 100 minus Y. So I'll do that to this side, and then I'll do that to this side. And so if we look at this term right here, this is pretty much like what the the reserve end is at. So like after the whole trade happens, 100 plus X over 100 minus Y, that's like the ending reserve. So that's pretty much equal to X over Y. So we can replace this whole thing with P. So that would look like P times 100 minus Y is equal to 10,000 over 100 minus Y. We know P is equal to 10 because that's the price we want to get to. And so now all we have to do is just solve for Y. And so to do that, I am going to bring this up here. So that will look like this. 10 times 100 minus Y times 100 minus Y is equal to 10,000. Running out of room. I can divide both by 10. I'm going to go over here. So 100 minus Y times 100 minus Y is equal to 10,000 over 10, which is equal to 1,000. I'm just gonna okay. Yeah, and then so we can multiply these out. So this is 10,000. Then this is minus 100y, and then that's minus 100y, and then this would be plus y squared is equal to 1,000. And then I'll just kind of isolate everything on one side. So that would be y squared minus 200y plus 9,000 is equal to 0. And so this is like a quadratic equation, so you got to find the root. And I'm not going to do that by hand. I'm just going to plug it in here.
Oh man, cheater. So this is the root. I want the approximate. So, I mean, it could be either one of these. Usually one will be negative and you're like, okay, it can't be that one. But I'm just going to see if 131.62 works. So if y is equal to 131.62, so then that would look like this. Shit. This would be 100 plus 131.62 equal to 10,000. So in this case, x would be equal to 1,000 over. Isn't the right side gonna be negative? Like 100 minus 131.62?
Oh yeah. Okay, that's what it is. So it's gonna be negative for sure. So it can't be this one. Because that would be greater than 100. So it's got to be 68.38. Good call, Sid.
Taking me back to high school, man.
So I got x is equal to 216.25.
So if you want to see the reserve at the end of all this, it would be 100 plus 216. That's 316.25. Then it'd be 100 minus 68.38. This would be 31.62. And then this times this should be equal to 10,000, but we can just double check. And it does equal 10,000. So everything seems good. So now if we want to see the price, it would be 316.25 USDC over 31.62 FTM. 316.
10 bucks, dude.
Yeah, $10. That's what we were looking for. Yeah, so that's how to calculate how much input you would need to reach a certain price. So in this case, of a reserve starting with 100 USDC and 100 FTM at $1, you would need to put in 216.25 USDC in order to get Phantom up to $1. So yeah, if you want to do this on, let's see, like if you wanted to do this on Spirit, in Spirit FTM and see like how much FTM you need to get Spirit up to Spirit equals 1 FTM, what you would have to do is go to the pair on FTM scan. And then, so this would be your reserve here. So there's about 80 million Spirit and then 4 million FTM. But these numbers are going to be massive, so it might not be the best to like whiteboard it out right now. Yeah, that's all the math I had planned for today. Does anyone have any questions, or is there anything like specific anyone wants to see? I'll take a look at the question channel.
Well, Dennis, first of all, he should really thank you for all these information, because I mean, I'm sure that most of the folks are just like swapping, and they don't really know the maths behind it, which is very delicate. And I know it's a bit more complex than that, but still, it's a very good start.
Yeah, I'm a math oriented person, so like conceptually, like it really helped me understand like what was going on. Like if you want the price of an asset to go up, then like some of it has to be removed from the liquidity pool essentially, and then the other token has to be added. So yeah, it's a really interesting equation, and it's very fundamental in DeFi, because it allows us to have like units of liquidity, which is something that you never have really seen before DeFi, and I think that's really cool personally.
Yeah, the very fundamentals of DeFi, let's say. I'm waiting for Reshi is, I think, writing a question on the chat, so I'm kind of expecting. By the way, guys, if you would like to come up on the stage and have a chat with us, please just say it on the chat so that we can give you. You are muted right now, server muted, but we can just open the mic for you. So just bear in this. I mean, if it's too long for you to write the question, you can just ask to take a stand on the stage. Well, I think Rashi just didn't want to continue with the question, so I have got one at least another one. I think this is not the only way or the only equation that the AMMs work at the moment in DeFi. Is that true, Hish?
Yeah, so there's a couple different ones. So this was the first one, the constant product market maker. So what's really special about this one is you don't need to know anything about token A or token B. You just put them in and it works fine. But obviously, like in the real world, market makers, when they make markets, like they expect a profit off of it, and they use like very sophisticated data like volatility, and all this sort of stuff, all this data input to decide where to place their orders in the order book so that they can make money. So this is kind of like a dumb market maker in a sense, but it works really well for DeFi because on a blockchain, it's really hard to get input data. Like we would need oracles for everything essentially. And some AMMs do that. For example, like Dodo Dex, they use an oracle to like see the price on another exchange, and then they can build the market around that oracle. So that would be like much tighter slippage. But yeah, the other versions of market makers are the stable swap. So Curve has a stable swap, and then Andre's stable swap from Solidly is like x squared times y, or I think it's like y plus x times x squared times y squared equals k, like something like that. I don't remember exactly. But there's a bunch of whole different equations for different market makers, and so the way like stable swaps are able to concentrate liquidity is because they know like the price of USDC should be $1, so they don't need an oracle to tell them that. Like they can just like assume it in the contracts. So those work without oracles. And then you have Uniswap, which is like it's the same x times y equals k equation, but they concentrate it. I guess we can go into like what the graph looks like. So if on this side we have x, so say that this is USDC, and then this side we have y, so FTM. The graph of the AMM will look something like this. So say that 100 is right here. So this is like $1. And then say that we sold 50 FTM. Actually, say that we bought 100 FTM. So then that would make FTM $200 in the reserve, and then USDC 50. So now this would be like the new price right here. That would be 200 over 50, which is 4. And so that's kind of like what the graph looks like. And what Uniswap does is they concentrate the liquidity into like real zones. So say that like you only wanted to provide liquidity between here and here. This provides liquidity from 0 to infinity. But like obviously FTM has traded between like 20 cents and $3 for the past year. So there's no point of putting liquidity from 0 to infinity, because everything from 0 to 20 cents, like this liquidity right here is like not getting touched at all. And then anything from $3 to infinity, which is like a pretty massive range, this is not getting touched at all. Like the only stuff that's getting like actually traded on is right here. So it's like really inefficient to throw all your liquidity from 0 to infinity when you know like the price is ranging from a certain amount to a certain amount. And so that's what Uniswap v3 does. Like a LP can be like, okay, I only want to provide liquidity from 20 cents to $3. So it'll actually give them like a real curve right here. And then that allows for much more like capital efficiency when it comes to trading. So it's better for swapping for users. Although much more complicated for LPs. Like if you're a regular LP, like it'll probably be like pretty hard to make money LPing on Uniswap. Like you got to be pretty sophisticated. And it also kind of takes away the composability of an LP. Like you can't, like every different LP position on UniV3 is an NFT itself. So like one LP is not equal to another LP on UniV3. Whereas on UniV2, one LP is equal to one LP all the time. And that, like, another interesting thing about AMMs is there's sort of like a trifecta situation going on, where this is, let's say, Oracle, and then we have LP, and then we have swap. So this is like over here, we have how low is slippage. Like do people want to do a lot of swaps on this AMM because slippage is low? And then LP is like, how profitable is it to LP? Like, am I going to be like getting a lot of impermanent loss, or am I going to be like actually making money? And then over here, this is like, how reliable is this AMM as an oracle? Like, Uni V2 LPs are in a way like an on-chain oracle, because you can take the time-weighted average price from it and use it in other like DeFi applications. And so Uni V2 comes out like right here in the middle. But something like Dodo that takes in like an oracle feed, it would come in like somewhere, on this line, because it can't be an on-chain oracle because it needs that external oracle information. And then Uni V3, that one is like pretty variable. Like, it, depending on how good you are at being an LP, like it could be, closer over to this side, or it kind of solves the trifecta in a different way, but it also depends on like how good of an LP you are and how well you can compete against other LPs in the market who are very sophisticated. But yeah, that's, I guess, all I have there.
We have one more question about this constant K, and the Rashi is asking, is it possible for the liquidity provider decide the more X or Y in order to change K? So, because I mean, from what you have said, is like, I mean, initially whatever K is determined, it stays constant throughout all the time. Is this true, or is it possible to change it?
So it's true to an extent. Like, if you have 100 and 100, so any swap that happens here, K will always be the same. It'll always be 10,000. But if I come in and add liquidity, say I decide I want to double the liquidity. So now it would be 200 and 200, and K is actually recalculated when an add and remove liquidity happens. So now K is 200 times 200, which is 40,000. So any add or remove liquidity events, those affect K, but any swap events do not affect K. Is, I guess, the way to look at it.
Yeah, perfectly explained. Yeah, so it is also, when you look at for example, some statistics or the pool movements, it's the addition, removal, or swapping are like considered the three different actions. And by looking at those actions, you can in fact determine or can see what K is, or what the ratios are changing due to K being constant. So yeah, that's really perfect. It is like 45 minutes, by the way, Hish. Thank you very much. I mean, it was very explanatory. I just would like to see if you guys have a couple of words to any updates to give to the community, or I'm still waiting for some questions from community if they would like to ask. But if you would like to give some updates or talk something about else, we can wrap this up slowly, I guess. What do you think?
Yeah, feel free to ask whatever.
I guess one question that I have for you guys for next week, what would you guys want to like listen? Do you want to like do like deploying of your own token or your own NFT? Like you guys would all deploy like your own token, or do you want to like do more of like a financial topic? Like let's say you want to like talk about options, like puts and calls and whatever. What's kind of like your preference? Put it in like chat or like say it out loud, so that we can plan like better for next week.
Yeah, people are. Yeah, there's. Oh my god.
Eyebrow raises.
We had already given the hours. I mean, you missed it. Just weeks. We gave the hours.
By the minute. But yeah, if you guys have any like things specific you want us to cover for next week's Sully Fireside, just throw it in the chat. And we will cover it.
Yeah, the chat is always open. We are looking at it. So if you just give us some ideas, that would be really nice for the team to get prepared, at least for the next week. Zaro, are you there?
Yep.
Want to wrap this up? What do you feel?
I think we can do it. If she's finaled and wrap the topic up. What do you think, Ish?
Did
Are we good?
the professor has to give some homework to everybody? Like,
Yeah. Maybe we can add some reward for the homework as well.
Yeah,
For the next week.
let's say how much FTM needed to get to 1 spirit equals 1 FTM based on the SpiritSwap liquidity pool.
who
Ooh,
solves
nice
this would
question.
get whoever solves this gets 500 spirit as a reward. I'll throw it in.
All right. He's checking the
Wow.
homeworks next week, boys. Don't come late.
That could be an interesting one, Sid. Explanation on how to pull data from a chain database.
Like, what do you mean chain database?
I mean, I guess like any database in general that stores like chain data, like
So
Copilot.
it is usually APIs, Jack. Whoever is asking the question, like let's say we are using Covalent. Covalent stores this information on their database, and then we use APIs to pull that data. You could write your own script to like store it on your own database as well. Depends on like what you want to like do. Like either way, you could use somebody else's API, or you could build your own like database. If that answers your question, like we actually have a document being added to Gitbook. Hopefully, I'll add it by next week. On how you can pull covalent data and build our analytics dashboard, like all by yourself. So I'll put that in the Gitbook, and we'll put out an announcement.
All right, cool. I guess we can wrap this up.
Yep. All right then, guys. Hish, thank you for teaching us the deep side of crypto, I could say. Yeah, guys, if you have any questions, please ask now, or we will wrap this up now. Reachabay is typing. Thanks, man. Thanks a lot.
Thank you guys for joining us today, and looking forward to the next one.
Yep. Thank you again. All right, guys. See you next week then. Cheers.
See you all. Bye bye.